Hi guys, this is O-Level Chemistry, paper 11, November 2018, question 21. Insoluble salts are prepared by reacting aqueous solutions of soluble salts. A precipitate is formed. Which pair of aqueous solution forms a precipitate? So, barium chloride reacting with nitric acid. Okay, so nitric acid has the anion nitrate in it, and all nitrates are soluble. So, in this case, precipitation will not be observed. Next, barium chloride and sulfuric acid. This has the sulfate ion. This would result in the formation of barium sulfate, which is an insoluble salt, so a precipitate would be observed. Next, barium nitrate and nitric acid. In this case, since the anion is the same, nitrate in both cases, there would be no reaction taking place, and even barium nitrate is soluble, which we have already discussed, so precipitation will not be observed. Next, barium nitrate and sulfuric acid. Sulfuric acid contains a sulfate ion. When it reacts with barium ions, it would form barium sulfate, which is an insoluble white precipitate. So, precipitation will be observed. So, in reactions 2 and 4, precipitation is observed, and in 1 and 3, precipitation is not observed, making C the correct option for this question. Question 22. The diagram shows the main stages in the manufacture of an ammonia-based fertilizer. Okay, nitrogen and hydrogen gas are present in the presence of iron at 500 degrees Celsius and 200 atmospheres. Then they are separated and fertilizer is manufactured. So the first part, the one represented by X, is part of the Haber's process. What is happening in the process labeled X? In the process labeled X, nitrogen and hydrogen that have not reacted to form ammonia are being returned to the start of the system so that they would undergo the reaction process again, and maybe they would form ammonia this time because this is a reversible process. So let's see. Ammonia is returned to the start of the process to shift the equilibrium towards the product. No, this would not shift the equilibrium towards the product. The gases are cooled to cause ammonia to form a liquid. That is happening for ammonia in a separate part of the setup. Unreacted hydrogen only is recycled. No, both nitrogen and hydrogen are recycled. Unreacted hydrogen, nitrogen are recycled. Yes. So this makes option D the correct option for this question. Question 23. What is the use of sulfuric acid? As a bleach? No, that would be chlorine. As a food preservative, that would be sulfur dioxide. In the manufacture of detergents, yes, sulfuric acid is used. In the manufacture of vanadium 5 oxide, no. Sulfuric acid is not used in the manufacture of vanadium 5 oxide. Vanadium 5 oxide is used in the manufacture of sulfuric acid. It's the opposite of what is written. So this makes option C the correct option for this question. Question 24. Which property shows an increasing trend in the elements from group 1 to group 7? So basically along a period. So across a period of the periodic table. Ability to form anions. Yes, because if we look at any period in particular, let's take the example of period 3. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. These are cations and these form anions. So, increasing trend, increasing ability to form anions. So, this is correct. Metallic character? No. Metallic character decreases along a period. Okay. Number of electron shells, they remain the same. So, this is also incorrect. And reactivity with water, Now the reactivity with water is very much different. Sodium and magnesium do react with water. Aluminum and silicon do not. So the activity of water varies, because if aluminum and silicon do not, that does not mean the others don't. Chlorine does react with water. So this varies from element to element. So as a result, the correct option for this question is option A. Question 25. The melting point of lithium is 181 and the melting point of sodium is 98. So lithium is on top of sodium in group 1 of the periodic table. Which statement explains why lithium has a higher melting point than sodium? Lithium has more valence electrons than sodium. No, they have got the same number of valence electrons. Both are in group 1, so one valence electron. Sodium is more reactive than lithium. Yes, this is true, but it is not a reason for sodium having a lower melting point. Sodium is softer than lithium. No, lithium is softer than sodium. The attraction between the positive ions and the sea of electrons is stronger in lithium than in sodium. Yes, because the metallic bond strength is stronger in lithium than in sodium, lithium would have a higher melting point. So the melting point of metal is dependent on their metallic bond strength. The higher the metallic bond strength, the higher the melting point, and the lesser the metallic bond strength, the lesser the melting point of the metal. So the metallic bond strength of lithium is stronger than that of sodium, making its melting point higher than that of sodium. So this is correct. Therefore, the correct option for this question is option D. Question 26. From their position in the periodic table, which properties would you expect the elements vanadium, chromium, and cobalt to have? So all three of them are transition elements. So the properties we are looking at should be the properties of transition elements. Variable oxidation state is a property of transition element. Forming colored compounds is a property of transition elements. And high melting point is a property of transition elements. So all three properties belong to transition elements, which means all three properties are correct, making option A the correct option for this question. Question 27. The diagram shows the structure of an alloy. Which statement about alloys is correct? Alloys can only be formed by mixing copper or iron with other elements. No, there are other alloys in which copper and iron are not present. So this is incorrect. High carbon steel alloys are soft and easily shaped. No, they are very hard. In an alloy, there is attraction between positive ions and a sea of electrons. Yes, this is correct because alloys are metals and metals have a sea of electrons being attracted to the positive ions that are present. So this option is correct. And the last one, the alloy brass has a chemical formula. Brass is a mixture of copper and zinc. So it's a mixture, not a chemical compound, so it will not have a chemical formula. Therefore, the correct option for this question is option C. Question 28. The list shows the position of metal X in the reactivity series of metals. Okay, sodium, aluminum, iron, X, copper, and silver. Okay, so this is more reactive than copper and less reactive than iron. Okay, which method would be used to extract metal X? Electrolysis of solid metal oxide? No, these are for metals that are more reactive than iron. So this is less reactive than iron, then this would not be used. Heating the metal oxide with carbon, this is true for iron and the metals below iron. So X is below iron, so this is correct. Okay, heating the metal oxide with copper. So if we heat the metal oxide with copper, that means copper has to be more reactive than metal X, whereas copper is less reactive. So this reaction will not happen. So this is incorrect as well. So only method 2 is correct, making option C the correct option for this question. Question 29. An old commercial process for aluminum extraction uses large quantities of sodium to convert aluminum ions into aluminum atoms. The modern aluminum extraction process uses electrolysis. Which statements are correct? In the old process, the sodium acted as an oxidizing agent? No, because aluminum ions are being converted into aluminum metal, it acted as a reducing agent. The reaction worked because sodium is more reactive than aluminum. Yes, in the reactivity series, sodium is the most reactive metal. The equation for the cathode reaction is Al3 positive plus 3 electrons gives Al. Yes, this is the modern process. This is true. A cathode is where reduction takes place and aluminum ions are reduced to aluminum metal. And the carbon anode needs replacing often because it is oxidized to carbon dioxide by the oxygen evolved. Yes, oxygen is produced at the anode and the anode are made of carbon. So at the high temperatures used, carbon anodes burns away in oxygen as carbon dioxide and needs to be replaced constantly. Okay, so which statements are correct? So in the old process, the statement that is correct is 2 only. So automatically options A, B, and C have been eliminated. Option D is the correct option. And in the modern process, both options are correct. So option D says 3 and 4, which is true, making option D the correct option for this question. Question 30. Which element is always present in steel? Okay, so steel is an alloy which has the main components as iron plus carbon, and in small amounts we would have sulfur, phosphorus, manganese, nickel, and chromium. Major components being iron and carbon, minor components being sulfur, phosphorus, manganese, nickel, and chromium. So out of these, the options we have are calcium, not there, copper, not there, iron is there, and zinc, not there. Therefore, the correct option for this question is option C.